We need a much more developer-friendly way to express my application can open these files and talk to these endpoints.
You mentioned a developer friendly. Why is it that it's talking about being developer first in the cloud native space?
When you're developing an app, security might be treated as an afterthought. With functionality requirements and tight deadlines, it's easy to accidentally write vulnerable code or use a vulnerable dependency. But Sneak can help you secure your code in real time, so you don't need to slow down to build securely. Develop fast, stay secure. Good developer. Sneak.
Network security is no longer about IP addresses. It's way more than that, especially in the cloud native space where we have managed Kubernetes and unmanaged Kubernetes. There's a lot more deeper that you can go into the kernel level and still have that abstraction level to the point that you understand, hey, I can have a defense in depth policy, which allows me to identify things like seccomp for people who may have done work in the Linux world, or selinux for people who may have worked in the Red Hat space. All those network security policies that we used to develop with selinux. Hey, how can I interact with the kernel in a way that I can prevent anything wrong from happening before it happens as well? This is where the answer was for eBPF. For this, we had Liz Rice from Isovalent, who spoke about her book, Learning eBPF, eBPF in general, and why is it required in the Kubernetes space. What are some of the challenges that are probably, or maybe even the gaps that are left with Kubernetes where network security has to be dealt in a different way? And this was really interesting. We spoke about multi-cluster. We spoke about the traditional use case for how network security used to be. We also spoke about the developer-first world of maturity that Kubernetes space is getting to. Funny enough, cloud security space is getting there as well, and the cloud native security space is getting there as well, where all of us collectively are realizing that, hey, at the end of the day, it's developers who need to solve this problem. And we can only just identify it and protect it in front of them. What's the easiest way to solve them is on how easy we make it for them to just solve the problem by clicking a button or by making it available exactly at the place where they are. I hope you enjoyed this episode of eBPF. If you are watching this, we are at KubeCon EU next week. Another interesting fact about Liz, she's riding from London all the way to Amsterdam for KubeCon EU. So if you see her, definitely say hello and take a picture. I would love to get tagged on it because I think it'd be an awesome ride. And if you see us at KubeCon EU, definitely say hello. We're running a meetup panel to talk about what's new in KubeCon and why people should care about KubeCon for the local community at the Cloud Security Meetup. Definitely check that out. I'll leave a link for that in the show notes as well. If you're attending, definitely say hello there. And if you or someone you know is trying to learn about the whole eBPF space, network security in the Kubernetes land, definitely share this episode with them. eBPF is going to be the foundational piece on which a lot of network security is currently being built on, because you can have a custom protocol within a kernel. Yes, that's a hint for what's being discussed on the episode. Definitely share this with them. And if you're someone who's listening to this for the second or third time, I would really appreciate if you can give us a follow or subscribe on your audio platform like Apple Podcasts or Spotify. Or if you're watching this on YouTube, actually, you can watch this on Spotify as well. If you're watching this on YouTube and LinkedIn, definitely give us a follow there. By the way, we are running a cloud security bootcamp over there. If you are someone who's trying to learn about AWS security in a practical way, definitely check out the playlist that we have running over there for the cloud security bootcamp. And as always, I hope you enjoy this episode and get value from it. I will see you in the next episode. Hi, Liz. How are you?
Hello. Yeah, I'm great. How are you?
Good. Thank you for coming over. I doubt many people don't know who you are, but for the 5 individual in the crowd who do not know who you are, could you just give us a brief on a bit about yourself and how you got into the space?
Yeah, so my day job, I'm the Chief Open Source Officer at Isovalent, which is the company that originally created Cilium, which a lot of people know as the networking plugin for Kubernetes. Cilium is based on eBPF, and I've been interested in eBPF kind of ever since I first heard about Cilium. So that's kind of how I got involved with Isovalent. And then I'm on the governing board for the Cloud Native Computing Foundation, which is the organization that essentially behind Kubernetes and the whole family of cloud native projects. And I'm also on the board for Open UK, which is an organization promoting the use of open technology. So, and I write books as well. So I'm kind of busy. Yeah.
I'm like, just one more thing over there. I'm also curious as to, were you always in the cloud native space, or what was your transition in? Because I feel like the cloud native tech may have existed for a long time, but a lot of people came from different paths. What was your path into it?
Yeah, so my career started off with software engineering, mostly in network protocols. And I did that for quite a long time. So I do have this kind of networking background. Then I went off to some more user-facing companies, like I worked at Skype and Last.fm on some recommendations technology, got into recommendations tech for a little bit. And as part of working on a startup, I remember the first time I ever heard of Docker. Our recommendation startup was in an accelerator, and the company next door to us, their CTO was telling us all about this amazing new thing called Docker. We're like, okay, that seems interesting. And a few months later, I was getting really interested in containers, and from there it turned into a journey of like, well, what are containers? And then how are they isolated from each other and from the host? And there's a whole security implication here. And then I got really into kind of how container security works. And as part of that, I could see the benefits of eBPF kind of coming down the highway. And so that's kind of how all the dots connect to where I am today, really involved in the eBPF space, particularly in cloud native.
And to think it all started with a conversation over a lunch table or something, I guess.
Hey, yeah, I mean, this is the thing. The most inspiring, little nuggets of information can quite often come from hallway track,
Yeah. Oh, actually, that's probably talking about hallway track as well. It's a good point. With eBPF, how would you explain it to people who probably have never heard of this? Like maybe like a 5-year-old. I'm going to sound like ChatGPT now, but tell me like it's like a 5-year-old.
Yeah. So the acronym stands for Extended Berkeley Packet Filter. And I basically recommend people forget that straight away, because it does so much more than filtering packets now. It's really enabling us to run custom programs inside the kernel. In fact, there's some language being debated now about, well, what if we want to run eBPF in environments that don't have a specific kernel, like kind of embedded operating systems that maybe don't have that split? Well, it's all about running custom programs within a privileged environment. But for most of us, we think about, the Linux kernel. We can think about changing the way that the kernel behaves. And this is really interesting because most of us don't spend a lot of time thinking about how the kernel behaves. We think about applications, and it turns out whenever our applications are doing anything that's interesting, like sending or receiving network messages or allocating memory or writing something to a screen, accessing files, all these things involve hardware. And applications can't talk directly to the hardware. They use the services of the kernel to do that. And that means the kernel's involved in everything that's interesting from a security perspective. The kernel's also controlling things like privileges and permissions. So if we can customize the way the kernel behaves, if we can get information out about what's happening in the kernel, we can use that in really powerful ways for all sorts of infrastructure tooling, including security tooling.
Wait, so because I believe at least Kubernetes and cloud native has always had a origin story in the traditional on-premise environment, what would have been the traditional business use case for something like this in a regular on-premise world? Because to your point, you mentioned kernel and programming within kernels, custom programs within kernels. What was like the traditional use case for this? Or is this like a cloud native unique problem?
So it's not at all cloud native unique, although it lends itself really nicely to cloud native. But a lot of us will have used things like seccomp. And the version of seccomp that we've been using for a long time is actually, its official name is seccomp BPF. And it uses essentially a very early version of BPF programs to perform this kind of filtering behavior on, am I going to allow this system call or not? So that's probably the use case that many people will have come across without realizing. Another example would be tcpdump, that's using eBPF to extract information about network packets. So yeah, there's a few use cases that have been available for quite some time in older kernels. Now, as eBPF is developed in the kernel, it actually takes a few years typically before the version of the kernel makes it into production environments. If you're running Red Hat Enterprise Linux, it's probably based on a kernel that's a few years old, because they want to be sure that it's really field hardened before they roll it out to, enterprise production environments. But we're now at the point where those kind of versions of the kernel that everybody is now using in production have pretty advanced eBPF support, so we can do lots of really interesting things with it as a platform. And then the reason why it's really interesting for cloud native is however many containers you're running on a given virtual machine or bare metal machine, they're all sharing one kernel. So we only have to instrument that machine once with eBPF programs, and then it has visibility into and it can influence the behavior of all of the applications that are running on that machine. So in a Kubernetes environment, we don't have to instrument every single pod. We can instrument just each node and get the effect of instrumentation across everything that's happening on that node.
Actually, because it makes me almost feel like, wait, so would SELinux be also an example of this?
So SELinux is not using eBPF, although there is a kind of overlap here in that SELinux uses an interface inside the kernel called the Linux Security Module API. And in pretty recent versions of the kernel, you can actually attach eBPF programs to that same API. So rather than having these quite fixed SELinux profiles, you can have dynamic, custom, like you could write an eBPF program to do pretty much anything you like on that LSM interface. So we can have much more kind of flexible policies, maybe context-dependent policies. There's a lot of really cool things that we can do with that interface.
Okay. To your point, then maybe another way to put this across would be the traditional use cases. We've always been working on this in one way or the other, whether it's seccomp or any other way of looking at this. Why is this I find it very ignorant as I said, why is this a problem that we're solving in Kubernetes now? And why not maybe, Kubernetes have been there for some time. Is there a reason why this is popular now versus, 5-6 years ago?
Yeah, I think it really speaks to the versions of the kernel. So eBPF has been enhanced, from its early days originally it was just doing packet filtering, and then we started to see things like the seccomp, let's have some customizable behavior that we can attach, to look at different system calls and decide whether to permit them or not, to a much greater range of different attachment points in the kernel. So you can now attach to basically any K probe, pretty much anywhere in the kernel. You can attach to U probes in user space. You can attach to a variety of different points in the network stack. It's taken, a few years for that. Every new attachment type involves work, real expert people like my colleague. One of the reasons why I was really excited about joining Isovalent is, the expertise that the team has in the kernel. There are 3 maintainers of eBPF in the Linux kernel, and one of them is Daniel Borkman, who I now get to, work with at Isovalent, which is, he's just an amazing, the knowledge that he has about the kernel, and, he's been involved with eBPF right since the start. So it's really fantastic to kind of get his perspective on things and get his stories and yeah, some really great knowledge there.
I think we started this conversation at a place, and I thought it was really interesting as well. There was a reason why a lot of this was abstracted from normal users, like application cannot talk directly to a kernel, because people would have thought there's a lot more complexity coming in. And with public cloud coming in, we're even more abstracted from hardware. Kubernetes also now is going into, or at least cloud native is also going down that path where it's managed and unmanaged. What would be the use case for this in a context where it is managed Kubernetes versus an unmanaged Kubernetes?
Yeah, so I think I've talked about, we can use eBPF to customize the way the kernel behaves. In reality, most people are not going to write eBPF programs directly. They will use tools that are using eBPF as a platform.
Right.
So, for example, Cilium uses eBPF to essentially intercept network packets and kind of pass them from A to B in a really direct fashion, rather than necessarily going through the whole networking stack. And also doing things like using eBPF to do network policy. So we might drop packets if they don't match policy. And there are, a large number of people using Cilium in Kubernetes environments. So whether they know it or not, they're running eBPF programs that Cilium is creating and loading into their kernel for them. And I think the vast majority of people using eBPF will do it through a tool like that. There are several other projects that are using eBPF. And then whether or not they can use those tools in a managed environment very much depends on the environment. So, for example, all the major cloud providers now have, at least in some form, networking that's based on Cilium. So, for example, GKE's data plane V2 is based on Cilium. Azure have just announced that the Azure CNI powered by Cilium. US use it for EKS anywhere. So there are environments where people will find themselves using these managed Kubernetes or other managed services that may be using eBPF under the hood, even if they're not necessarily touching the kernel themselves. They will be getting the power of eBPF that way.
Interesting. So to your point then, if people are already using eBPF without even knowing it, is there because you know how even with Kubernetes as well, I'm sure there are like anti-patterns and I guess the right way of doing it. Have you identified any anti-patterns for how people have implemented eBPF versus how they should have?
So one really interesting case, particularly in the security space, we talked about seccomp BPF and intercepting system calls. And seccomp BPF itself is safe, but you can also hook eBPF programs to the K probe at the entry and exit point from making system calls. And there was a really interesting talk at DEF CON. I want to say it was, we might be coming up to 2 years ago. I can't remember if it was last year or 2 years ago now. But it was a very interesting talk about how that is not necessarily safe, because if you, at the point where you make a system call, that your user space application is passing some parameters via that system call, and they have to be copied into kernel memory. And if you intercept the system call before the parameters have been copied into the kernel memory, then there is a window of opportunity for an attacker to change what those parameters are. So, for example, if it's, a pointer to a path or the file that you're about to open, and there is a possibility of changing the path that you're about to open, that's, not a great basis for a security tool. And it's actually interesting, if you kind of dig into the kernel documentation, there's a point in the documentation where it actually says, do not use this as the basis for a security tool. And yet there have been some eBPF-based security tools that use that interface, unknowing that it's a perfectly fine way of observing what's happening in your system. It's better than nothing, but it does have this big label on it saying, don't use this interface for security purposes.
Interesting. Because I guess this is an interesting debate as well. Another one that is very, in a way, similar, but works on a very different landscape. Like people talk about OPA quite a bit as well, which is like an access management and very different layer. And for drawing comparisons, would this be like a similar kind of experience for people where, I guess, because how a lot of security people would have choices whether you can go, should I do network security? Should I do access management? Should I do both? In a typical Kubernetes kind of environment which is implemented, do you find that one is enough, or do you need both? Because I feel like if we are going down the path of using Cilium or any other product, are we adding complexity onto the build and slowing it down, or whatever that people used to complain about in the traditional environment? Because I remember in a traditional environment, people were like, oh, if I put antivirus, if I put this agent, I put that agent, like everything just slows down. But Kubernetes is known to be just like really quick and just works really well. So do all of this combine? A, do people use all of these together? B, does that slow things down, or is that just works fine in cloud native?
Yeah, I mean, I'm definitely a believer in defense in depth. So, you kind of have to make your decisions about how much risk you are able to accept and how much, how tightly you need things to be locked down for your particular environment. But I would never say, you don't need that. Like, well, maybe you do. The nice thing about eBPF is that it is typically very high performance, because you can make decisions inside eBPF programs without having to transition between user space and kernel, which is usually pretty time consuming. So I've seen one data point that relates, it's actually came from Kepler, which is a eBPF project used to measure the energy use of different applications, so that you can decide whether your applications are, essentially to help optimize for being greener. And if you're going to instrument all of your applications, and it's pretty fine-grained measurement. But I think from memory, it was only going to be about 2 or 3% overhead, which is not bad for the extent to which they were measuring a lot of really detailed information. And I think that kind of level is, if you can get a huge amount of security benefit and insight and control for maybe 2 or 3% performance cost, that's probably a price worth paying. Now, it's certainly possible to implement eBPF programs. They're no different from any other software engineering. You could write them really badly and make them really slow if you really tried.
Oh, and maybe that's kind of where I was coming from, because the anti-pattern or security products come into is, we all believe in defense in depth, but we also believe in just, I guess, having all kinds of layers slow down the application. I was thinking of a nicer way to put it. And that's kind of where the question was coming from. As the cloud native, I guess, applications are a bit different. Sounds like they are a bit different. Because in traditional context, the moment I put like an antivirus agent or IDS, IPS kind of agent, that's it. Basically, it's not gonna function much as maybe not always, but it definitely tends to not function that well. So to your point, then, I love this is going as well, because I think another thing that people talk about in the Kubernetes space, where sometimes a lot of the challenges come in, is the whole multi-cluster space as well.
Mm-hmm.
So I guess for people who are thinking about multi-cluster, before we go into the whole EBPF and multi-cluster, like, I think what are some of the challenges that you feel people see in the multi-cluster Kubernetes deployment?
So I think one of the reasons why people use Kubernetes in the first place is the ability to say, I can take my application and run it, using the Kubernetes APIs anywhere, in different public clouds and my on-prem environment, if I have Kubernetes as essentially a distributed operating system. And that is true to an extent, but at some point you have to provision the infrastructure in the first place. You may have different things like network, VPCs connecting your networks together across different clouds and across different environments. So there are definitely some challenges involved. It's actually something that we're really working on a lot at Cilium to try and simplify this, because a lot of the approaches around kind of connecting multiple clusters or connecting multiple clouds or connecting to external workloads seem to involve adding new kind of abstractions. And in Cilium, we've been looking a lot more at like, well, can we just reuse the existing abstractions? Like in Kubernetes, we have the idea of a service. So, we expect our pods to be able to access a service by its kind of service DNS name. And we don't care about which pod is backing that service. And Cilium has a feature called multi-cluster, where you can take services in more than one cluster and basically advertise them as, well, these are the same service. And it's just a case of labeling the service. We connecting the two clusters together and sort of authenticating them to each other. And then from the perspective of somebody who's writing an application that wants to access one of those services, it just looks like a service. They don't have to care. You can do things like sort of affinity such that it's going to always prefer a local instance of the service if one is available. But if it's not, then there is an ability to fail over to a remote service. So it's kind of really about paring back and using the fact that with eBPF, we can connect at this within the networking stack, and we can make some interesting decisions about how we handle packets right there in the kernel without having to pass things, up and down the stack near as much. So there's a lot of really cool work coming to simplify the way that we, at least at a network layer, and then on top of that, the network policy layer, think about these multi-cloud services. So yeah. I'm actually doing a talk about this at KubeCon next week. So,
there you go. A teaser into that as well. Oh, because I was also thinking of key management as well. A lot of the networking involves, I guess, some kind of encryption transit.
Mm-hmm.
Do you find that key management is something that I've always heard of being a challenge in multi-clustered? Is that something that you find at large scale implementations of, I guess, doing networking in a multi-cluster Kubernetes environment? Is that something like a challenge as well, or is that just human created problem?
I mean, it absolutely is a challenge. And I think the answer to that challenge is going to be automation as much as possible. So using things like Spiffy Inspire or Cert Manager, automating the creation of keys and automating the distribution of keys to the appropriate kind of entities. I'm quite a big believer in, a bit like when Kelsey Hightower did the, Kubernetes way, let's go and do everything by hand and understand how it works. I think there's a lot of value in people understanding how keys work by going through the manual process, but you can't manage, keys at scale manually. So yeah, automated tooling is the way forward.
What do you see as the gaps at the moment? Because I think on one side, at this point in time, we've kind of spoken about like the good things about network security and how we can have custom packages and protocols to do network security better in the Kubernetes space. Because this is an existing gap at the moment, which just obviously was not filled by Kubernetes, like as in the traditional Kubernetes. That's why we have eBPF and Cilium and all of that. What are some of the other gaps that you notice in this space that are adjacent to this that are probably not being filled at the moment, or maybe are filled?
Yeah, so I think particularly if I think about runtime security, there is a gap in how we express security profiling in a human readable way. And things like OPA and Rego policies have made that a step forward. But in much the same way that we express firewalls and network policy, we start to express those. We used to express them in terms of IP addresses and ports, and that quite quickly gets a little bit like brain bending, to try and keep track of that. In a Kubernetes environment, we want to be thinking of things in terms of service names and services rather than IP addresses, because the IP addresses are dynamic. So we start using these slightly more human readable terminology, and it becomes, I'm not going to say that reading a network policy is super intuitive, but it's much easier to understand. My front end service can talk to my back end service. That's we're going to express it in those terms. I think we need similar, if not better, ways of expressing how runtime security should work. We talked about seccomp profiles and SE-Linux and how complicated they are. I think we need a much more developer-friendly way to express my application can open these files and talk to these endpoints, and maybe it's going to call this script, and it should never do anything else, and be able to express a policy in a way that we can really, in the same kind of sort of level of abstraction as we think about opening files and communicating with services and running scripts.
I was also going to ask, in terms of, you mentioned a developer friendly, because in all the conversations that I've had this month about cloud native, everyone mentioned that term developer friendly, developer first. What does that mean for you? And why is it that everyone's talking about being developer first in the cloud native space?
I think that's really interesting, isn't it? I think it speaks a lot to the maturity of Kubernetes. We almost expect the platform level to be Kubernetes. Lots of problems are being solved, but we are now, faced with making it accessible for developers and not requiring developers to understand every single detail of Kubernetes. I actually saw an interesting thread on Twitter just this morning about someone who is, as a developer, being required to learn Kubernetes. And I thought, well, is that such a bad thing? Well, only up to a point. A bit like if you're a developer, I think, if you're using Linux, you probably have to learn some commands to, list files and, just do basic operations at the command line. But you don't need to understand how the whole system works, and you don't need to understand how the kernel works, and you don't need to understand all the details of how, permissions and capabilities are
key management as well.
Yeah, exactly. So I feel like there's a similar parallel in the Kubernetes world. People shouldn't have to understand the entire stack. They just have an interface that they use that they can be familiar with.
And what would that look like in this context? Because I feel like the network part is always most, how do I put this? There's always been a split between a developer and a sysadmin. Having come from a sysadmin kind of background, there's always this thing that I'm building a server, I'm building a network. I just hand over the server to someone, whatever the server name I call it. And then from that point onwards, the developer, he or she would just take on to the next level of, okay, then I guess I'll build my application. Oh, look, Ashish, it doesn't work anymore. I can't connect to this web application. Can you help me out? There was always this delineation, but now with cloud, I feel that delineation is kind of fading away. You find the same in the cloud native space as well, where the separation of how much of it was, I guess, abstracted from the developer is not much abstracted. Like they kind of need to know some of it to at least be aware of, oh, I can't always just reach out to Liz or Ashish. And not that in the context of, hey, I can't reach out for help, but more in the context of, oh, this is part of my job. Like the same way people used to have PowerPoint, Word as a skill set in a resume.
Yeah.
Now it's almost expected that, oh, you probably should know this already, or at least Google Doc or whatever. I feel like, are we going in that direction as well with Kubernetes and cloud and all of that, where it's going to be expected rather than, hey, you need to add this in your skill set?
I think that's actually a really nice metaphor. If we think about how intuitive something like, using Google Docs or PowerPoint or, those apps are, if you're sort of familiar with the general way that applications work, you can put a presentation together, things work in the same way. I think if we can get the developer experience on Kubernetes to be as intuitive as that, would be a really great end goal. And I think that's what a lot of the kind of platform engineering, developer experience, debate, that's why that's happening, because it isn't today anywhere near as intuitive as or an IDE. If as a programmer I can fire up an IDE and I've got a pretty good idea what sort of things it's going to do for me, and I'll have a little bit of a ramp up to learn a new one, but not, it's probably going to be something that I can start to use pretty quickly. And getting Kubernetes to the same level that people can start feeling comfortable straight out of the gate without feeling that they have to study for an exam before they can use it.
Do a certification in identity security.
Yeah, I mean, there is certified Kubernetes security specialist or something like that, and there's a certified Kubernetes developer, and those exams exist because we don't have the sort of level of intuitive interface. I think the ideal would be that we don't need those exams anymore because we've got really nice tooling and abstractions.
Actually, yeah, that's true, because I don't know if there's an exam for PowerPoint or Excel.
Right.
Although they used to be, from pretty sure they used to in the beginning.
Yeah. If you want to get into really complicated, Visual Basic programming in Excel, there's probably a ton of really, studying that you can do to learn that. But for most of us, we don't need to do it. And I think that's a really interesting parallel to where we are with Kubernetes.
Yeah, I remember Access used to be a thing. Microsoft Access used to be like really complicated, and people would use it for really complex tasks. But I digress there. But I think the point is definitely made that we're all trying to make it accessible for developers, because at the end of the day, they're the ones who are developing the application. It's all about, I guess, the application that builds the business forward. And if we can make it easier for them to adopt it and accept it and work towards it, I think definitely would be a great place to be, which almost makes me a good segue into my next question about the future of eBPF as well. Where do you see this go from where it stands today?
Yeah, so I think we are at the beginning of a very rich seam of eBPF-based tools. So I think we'll see more and more interesting applications, particularly in sort of infrastructure tooling. So whether that's security, networking, observability, performance optimization, lots of kind of infrastructure areas where some really nice tools are being created. For eBPF itself, there is some, it continues to be developed in the kernel. It also is being developed not just in Linux. So Microsoft now have an eBPF implementation in Windows operating system. Are we going to see eBPF in embedded operating systems? Are we going to have eBPF in the fridge? Yeah,
well, I guess, Kubernetes made it to submarines, so maybe this may not be far.
Yeah, and it's really interesting. When I first heard the idea of putting eBPF into Windows, I thought, well, how on earth can that possibly? Well, maybe you can build something that looks the same, but can you run the same eBPF program? And the answer is, in some cases, you can, because particularly for things like networking, the data structures are, if I'm looking at a network packet, it doesn't matter whether that's on Windows or Linux. The layout of the packet is identical. So you can run eBPF programs that, look at or manipulate network packets. They should be transferable from one environment to the other. And we have actually seen, demos of Cilium running on Windows now using Windows eBPF, which is really very cool.
Windows EBPF, that would be interesting. Wait, so actually, I'm just curious. You have a book on this as well. Where do you normally send people to learn eBPF? Because if developers and everyone are walking down the path of where eBPF and Cilium are going to be like a thing, where do you recommend people can start learning about Cilium and I guess just eBPF in general? Because it sounds like it's a very foundational level knowledge to know from a network security perspective.
Yeah. So there's a website called ebpf.io, which is the community site about all things eBPF. And there's lots of great resources linked from there. If people are, they just want to get a high level view of what is eBPF, I actually wrote a little book that you can download for free from the Isovalent site called What is eBPF, which is just giving that kind of overview of what it is and kind of how it works and why it's important. And then, if you're somebody who, like me, wants to get hands-on, I find it very difficult to learn things just from like pictures and diagrams. I want to feel the code. I want to experiment with things. So the book Learning eBPF has lots of examples, lots of code examples. And we also have on isovalent.com/labs a whole bunch of sandbox environments where you can explore and play with eBPF and Cilium and lots of related, I think, things like the Cilium Tetragon tool, which uses eBPF for security observability and then even preventative security. So there's lots of really cool hands-on labs that you can play with and get a real feel for what's happening.
Awesome. Well, I think for people who are watching the video, you can just look on the left shoulder of Liz and you can see the book as well.
The other one, yeah. There we go.
the B logo in there as well. That was most of the questions that I had. I do have 3 questions which are just to get to know you a bit more, at least for the audience. Non-technical, just simple ones. 3 questions I'll quickly go through them. The first one being, what do you spend most time on when you're not working on cloud native or eBPF?
I guess there's a couple of things that I spend time. One is cycling. I do quite a lot of cycling. I'm actually going to be getting to Amsterdam by bike, so for KubeCon next week. So if I look tired and people see me in Amsterdam, that'll be why. And I really like music. You can probably see behind me, I've got my drum kit and things. And I wouldn't say I'm very good. I'm definitely mediocre, but I quite like putting music together. So yeah, that's fun.
Like a producer.
Yeah.
Awesome. Second question, what is something that you're proud of but is not on your social media?
Something I'm proud of that isn't on social media?
Yeah.
God, isn't my entire life on social media? Oh, that's really hard. That's a really hard question.
Is your music on social media out of curiosity?
It is. Yeah.
It is.
Inside of Nine. Yeah, it is. It has a very languishing Twitter account, but yeah, it's... you can listen to Insider 9 on Spotify and Apple Music and everything. So
there you go.
Got my SoundCloud.
Right, we need to find something else then which you're proud of but is not on your social media. So primarily most of your life is on social media.
Yeah, I'm pretty public, I guess. Yeah.
that would do it. Last question. What is your favorite cuisine or restaurant that you can share?
Oh, I love anything really like with interesting spices and flavors. So yeah, I do really like Indian food. I really like, there's a spice mix called Ras Al Hanout, and if I ever see that, I'm like, oh, I love it, delicious.
Wait, is that like a dish or is that actually just a spice?
I think it's a mix, and it's sort of in, I want to say, kind of Middle Eastern food. What
so people would put that in like a chicken dish or like a, I don't know, meat dish or whatever.
Yeah. I mean, personally, I'm mostly vegetarian, but yeah, it's a lovely.
Oh, well, I guess we can put it in potatoes, I guess.
Yeah, you can. I'm not very strict about vegetarianism, but definitely think one of the things when you eat meat and you think, oh, they're missing out on a whole load of flavor. Actually, it turns out a lot of flavor is nothing to do with the, it's all about spices and fresh vegetables and freshness and quality of ingredient. And,
that's right.
A really great tomato sauce is a really great thing.
No, but that is definitely true as well. Oh, awesome. Thank you for sharing that. I'm going to look out for that spice as well. Where can people find you if they have more questions about eBPF and just the world of how do you cycle to KubeCon in 2 days?
Yeah, I'll be able to answer that better in about a week's time. Yeah, so I'm pretty much everywhere on social media. I'm Liz Rice. I will be in Amsterdam at KubeCon next week. So if anybody sees me there, do come and say hello. We'll also be giving away some copies of the Learning EBPF book. I'm doing a book signing, I think, on Wednesday. So if people want to come along to that, come and say hello, get a copy of the book. And yeah, I love that whole, that particularly now that we can get back to in-person conferences, the ability to actually connect with people face to face at these events is really, really great.
Definitely. And I think, well, I'm looking forward to seeing in person at KubeCon EU as well. And just talking all about the bike ride and what were some of the challenges when you make it across. But thank you so much for spending the time. And I'll leave those links in the show notes as well for people to come along and follow you as well. Thank you so much for spending the time with us. I really appreciate this. I'll look forward to having you again.
My pleasure. Thanks for having me.
Thank you. Thanks, everyone.